Hello, welcome to Anson Griffin's occasional series in Matlab tutorials. Today I'll be relying on an inbuilt Matlab demonstration of single camera calibration. So this, just to say, is not my work. I've taken it from their sample script and I've commented and put in hopefully helpful comments. So we want to actually have a single camera calibration, and we're going to recover the extrinsic and intrinsic calibrations. Now, some of the commands here I've listed: image set, montage, detect checkerboard patterns, estimate camera parameters. So I'm not going to go through it because this is fairly complicated stuff and it's not for the complete beginner. I have to assume you know some sort of stuff. So it's just to see if you have Matlab and you just want to run their script, that you can get the extrinsic and intrinsic and then an estimation of how accurate your calibrations were. So I've just put up a bit there about what the extrinsic parameters are. So that's on line 27 and line 29, the translation vector between the relative positions of the two reference frames and the rotation matrix. And then the intrinsic would be the perspective projection, the transformation by unit plane coordinates and the pixel coordinates, and the geometric distortion by the optics. So on line 42-43, just to tidy up as before, I assume I know this, and there's some helps there. So, and the lines 45 to 56 are the Matlab help files, or the Matlab comments. So on line 63 we use the image set, and that's going to take in an inbuilt set of checkerbox. I've run this before, so let's just see, can we find that? So there you are, you have those checkerboard patterns and you took them in with the, you took images with the same camera at different positions in the world space. And on line 68 I used montage to display them, 2 rows, 5 columns. On line 71, this is an upmarket Harris edge or corner detector. On line 71, detect checkerboard points. So it just finds black and white and it finds the corners. On line 74 we tell Matlab that the size of the square is 29 millimeters. And then we generate the world points, and then the magic sauce, we calibrate the parameter. So we estimate the camera parameters on line 78, and then on line 86 to 96 I got Matlab to print out the intrinsics of the intrinsic parameters of the camera. They didn't do that in the actual Matlab file themselves. Scrolling down a little bit, we got the extrinsic camera parameters, apologies. And then on line 116 in that section we're getting the reprojection error, so we just want to see how accurate was our camera calibration. And that is, we get a figure there somewhere if I can find it. There's the mean reprojection error per image. That's not actually the one I'm looking for, but there are 10 images in our data set, and you can see there it's giving you the reprojection error per image. There's the extreme parameters visualization. Yeah, I'll find the right one in a sec. Doesn't really matter that much. Oh, sorry, there we have it. On line 138, the estimation errors, which is that one there on figure 4. Okay. And then we just get there the principal points, and I'm just making the point that if you got within plus or minus 2 standard deviations, you consider it to be an acceptable level of error, and anything outside that you might think it would be a gross error, and you might delete that particular image from the set of 10 and you might go again with 9. Only a suggestion. On line 166 we got the principal point, we saw that. That's there. And there's the last bit. We're just getting the translation vector errors and we're plotting them, and then we just plot an ellipsoid. So in effect you're getting I can't think of the word, you're just getting an ellipsoid in the x direction and the y direction of the uncertainty of the location of each checkerboard pattern. So if you want to improve your accuracy, you could modify your calibration settings. You could take more calibration images. On line 243, you could exclude images that have high reprojection errors, as mentioned before. Okay, I've published there. So there's the published file. What's on screen there is the name of each file in that image set. You see there's a couple of fisheyes. There's the montage. I have the screen super zoomed, so I have to scroll across. As I'm repeating myself, we detect the checkerboard points there. We estimate the camera parameters there. We spit out the intrinsic parameters there. Extrinsics coming up. There's my plot. There's the camera that's fixed, and there's in world space there's the 10 images. We saw that before, the mean reprojection error per image. And there's the standard errors of the various camera parameters. And there's the principal point uncertainty. Okay, that's kind of it. There's our translation vectors uncertainty, and all that code is available if you have the requisite toolbox. I think it's 2014A or 2014B on. Okay, so thanks very much for listening. Bye.